very important. Now let's look at the practical aspect. I want you to understand the practical aspect. So let's break it off here. I just break it. Okay, let's say I break this wire over here. That wire I have broken it over there at that particular location. Now it's like turning off a switch. When you turn off a switch, it's like breaking a wire. Now this one, at this location you have 10 volts. We all have 5 volts, for example. At this location you have 0 volts. And now just for some time, I want you to imagine that these copper wires, they don't take in any energy. It's an assumption. They don't have anything, they don't require any energy, you can think. So since the wire is broken, this particular location will be 5 volts and this location on the right side will be 0 volts. If the wire is not broken, there's a potential difference. Now, please observe this carefully. From here till here, there is no potential difference, guys. No potential difference. Now, my question is, if there is no potential difference, will the electrons move inside? From this particular point, let's call this point A, this particular location A, and this location is B. Between A and B points, there is no potential difference. When there is no potential difference, do you think electrons will move because of the battery? Does the battery have any effect on the electrons? That's what I'm asking you right now. Answers, guys. If the question is not clear, you can just point that out also. I can also show you this practically. I mean, not practical, but at least you can see this. Now I have this battery here. I have this battery. This is the positive of the battery. And I have a wire. I'm connecting it. I'm leaving it free. I'm not connecting it to the negative. I'm leaving it free. So this is positive with 9 volt. And even this corner has 9 volts because potential difference, there is no difference. If I connect it to this one, then it becomes 0. The potential difference will be 9 minus 0. But since it is not connected anywhere, this whole thing has a constant potential difference. When there is a constant potential difference, will the electrons move in there? Amrit just gave me an answer. What he said, Hasini gave me an answer as no, electrons will not move. So Amrit told me that since it is positive and this metal block has electrons, there will be some movement of the electrons. I definitely agree, Amrit, but there are too few, very little bit of effect actually. But we are talking about the overall thing. When we talk about the overall wire, we can actually confidently say that there is no current supply in this wire or no net movement of electrons. Only few electrons that are affected by this. Let's ignore that specific point actually. Okay, I hope all of you got this point. Only when there is a potential difference, electrons will move. You can have an analogy with this, guys. I mean, you know this. I mean, this is. I can't remove it, but anyway, I can make a hole. I like to pop balloons, anyways. So I have this balloon. It has air in it. So my question is about the pressure. So I have outside pressure. Outside the balloon, there's a lot of pressure. And inside the balloon, there is pressure. Which is at high potential or high pressure? Where is this high pressure region? Is it inside the balloon or outside the balloon? High pressure, guys. High pressure is inside the balloon and low pressure is outside the balloon, relatively. Yeah, inside is high pressure, outside is low pressure. So when I pop this balloon, okay, so what happened is, that was fun, right? Not only kids, we can also enjoy that. Yeah, so when I popped that balloon, what happened was air kind of gushed outside. Air gushed outside because there's a pressure difference from outside to inside. As soon as I broken that balloon barrier, that pressure difference was observed and it just moved out. Inside the balloon, there was a constant pressure. So there is no net movement of air. Maybe there's not much movement of air. I mean, effective movement of air. But as soon as they broke that barrier, the balloon, the rubber covering or whatever, there's a pressure difference from outside to inside and air just gushed. So if you want movement of anything, there should be a difference. The same thing goes with mountains. Imagine there's a mountain and there's lot of water on top. Water flows from top of the mountain to the bottom. That's because of gravity. The potential difference that is created by the gravity. mgh formula from 9th class. So whenever there is a potential difference, any sort of energy difference, material will flow. So that's what is happening. And you might be wondering, whenever your parents would have asked you, maybe not this generation, our generation, we were always, we had a problem with fuses actually, at least when we were very young. Later on, that issue was not there. Whenever we need to actually change the fuse, a small metal wire, we need to pull it out and have a new wire over there. We were asked to wear rubber slippers actually. The reason is, even if you try to touch a switch, right now, I'm touching this 9-volt part and my feet are not touching the ground. I'm not touching the ground at any point. Right now, electrons movement will not be there into my body because the circuit is not closed. This positive is at 9 volts and my entire body is also at 9 volts. Since it's all 9 volts, there is no difference in potential. Electrons will not move and I will never get any shock. Even if I touch it, don't do this. This is just for a theoretical sake. Please don't do it. Even if I touch a live wire, 220 volts wire, without touching the ground, I will not get a shock because there is no potential difference, guys. But with one hand, I touch this. And if I touch my feet to the ground, the 220 volts and electrons start to gush through my body. And when they move through my body, what happens is it kind of deep fries all my internal organs, liver, kidney, and everything actually. Okay. However good your heart is, it will get deep fried because when there's a potential difference, there will be movement of electrons, and those electrons, they try to move through the salt water, salt surfaces of our body. And in the process, there's a lot of heat developed, and that will fry out everything possible in that scenario. Move on. Right, that's about potential difference. And I have one more slide. I want to conclude potential difference with this particular slide. So when we are going to do that, I want you to make some assumptions. I'm starting with 10 volts over here. So whatever I'm going to tell you, this is the practical approach, guys. Very, very important. Just follow 1 minute with me on this particular slide. Okay, extremely important. What is the meaning of potential difference practically? That's what I'm talking. Whoever wants to create stuff with electronics and all. So this is the reason. And even when you do experiments, when you try to understand the experiments that we are going to do tomorrow, day after tomorrow, this practical sense is very much required. Okay. So this particular location is 10 volts at the left of the battery, and at the right of the battery, it's 0. Now let us imagine this is the silver wire, super silver wire. Silver is the best conductor known right now. And imagine we're actually like it's a superconductive state. That means let's imagine this wire is not absorbing any energy from the battery. It's an assumption. Even this wire will absorb some energy. But let's assume for now. And since it is 10 volts and there is no other energy consumer between, I'm writing this as 10 volts. Okay. Again, at this location, if you observe this particular location, there's no other energy consumer. Again, I'm placing 10 volts over there. Yeah, sure, maybe graphene, true. But still, even for graphene and all, I got an answer from Amrut asking if graphene is good. Yes, graphene is good, but still every material will absorb some sort of energy. So that's why I wanted you to make this assumption of no energy for the wire. Okay. So 10 volts, 10 volts, 10 volts. And right now, at this particular point is also 10 volts. All right. Now let's talk about this point, guys. Here, bulb, it's an energy consumer. It will definitely take some energy. Let's assume that this particular bulb only takes, let's say, 2 volts of energy. When it takes 2 volts of energy, the left out is 8 volts, right? That's 8 volts of energy. Here again, it will be 8 volts. Here it will be 8 volts. Here also, it will be 8 volts. Why 8 volts? Simple reason, because that is the amount of energy this bulb is taking so that it could glow. It could convert that energy to light energy. Here it is 8 volts. Now imagine this particular TV will consume some energy. How much energy do you think it will consume? Any guesses? Any guesses, guys? At this point, it is 8 volts. How much energy would this point be? TV consumes more energy than bulb. So how much energy would it be? Right, so let's move backwards. This is 0 volts. Since there is no new battery between these 2 points, there's no new battery between this point and this point. So that's why I'm using. If there's a battery, then it might increase. So this is 0. This is 0. And since this is 0, this one also has to be 0. Okay. Now we have been talking about potential difference, right? So here you are getting that that essence of potential difference practically. The potential difference between the two ends of the bulb is 2 volts. 10 volts minus 8 volts, that is 2 volts. So that means battery is consuming 2 volts of energy from the, the bulb is consuming 2 volts of energy from the battery. And what is this television doing? It's 8 volts on the left and 0 volts on the right. So 8 minus 0 is 8 volts. So this television is actually absorbing 8 volts of energy, or in simple terms, the potential difference at the ends of the television is 8 volts. The potential difference between the ends of the bulb is 2 volts. Okay. The sum of the potential difference is actually the energy supplied by this battery. 8 volts plus 2 volts is 10 volts. But in reality, what happens is it is 10 volts. Here it could be 9.99, 9.98 at the top. Something like that, there will be a little bit of difference. But we try to simplify by making certain assumptions. So from now on, guys, whenever you hear potential difference, I want your brain to have some information. You can say that potential difference is the energy consumed by an electrical appliance. Okay, potential difference is the energy consumed by an electrical appliance. Here it's 2 volts, here it is 8 volts. Okay, but when you are asked in an exam or any of your slip tests or whatever, then you have to talk about it is the work done on a unit charge to move the charge from location A to location B. That's the theoretical way, and this is the practical way. So potential difference is kind of energy consumed. So these electrical appliances are consuming energy. The difference between those extreme points, energies at the extreme points, is called potential difference. This is a very interesting way to solve many problems. What I've done over here, 10, 10, 10 and all, it's a very interesting way. Tough problems in series and parallel can be solved with such methods actually. And by the way, the instrument that is used to actually obtain potential difference is called, anyone? What is the instrument that is used to measure potential difference? I got answer from Amrit. Anyone else? What is the name of the instrument? Let me give you guesses. Ammeter, galvanometer. Which among those two? Got answer from Hasini. What is the name of the instrument that is used to measure potential difference? Okay, so I tried to confuse you guys. Ammeter and galvanometer, they're used to measure currents, but voltmeter, it's not volta. Voltameter is again the cell that we spoke about by volt. But anyway, the instrument that is used to measure potential difference is voltmeter. So voltmeter. Now I brought in that particular point because if I have a voltmeter and if I connect one end of the voltmeter to the left, one end of the voltmeter to the left, and this is the voltmeter, and one end to the right, I will be measuring potential difference for the television. Okay, what it will give me is the value on the left minus value on the right. 8 minus 0 is 0. If I place the voltmeter at the bulb at this point and the other point, then it will give me 10 minus 8, 2 volts. So potential difference is measured with voltmeter. And did I connect that voltmeter in series or parallel? Please observe the sketch on the television.
Parallel.
Yes, that voltmeter is connected in parallel, guys. Why it needs to be connected in parallel? It's very simple, because you're trying to measure the energy difference between these 2 points. If you want to find the difference between these 2 points, it needs to be connected at those 2 points, and such a connection is called parallel connection. But when it comes to electricity, now let's say I want to connect. This is an ammeter, guys. Ammeter is an instrument that is used to measure electric current. Okay. Now, ammeter is connected in series because whatever electrons are flowing in the wire, I want those electrons to travel through the ammeter and back to the battery. Okay. Since I want to know, if you remember, the way we understand electric current is very simple. Guys, electric current, whenever you hear, I wanted you to understand two things. How fast are the electrons moving? How many electrons are moving, if you remember? Okay. So if you want to connect an ammeter to measure electric current in this wire, you have to connect it in series. Why? Because you want the electrons to flow through that ammeter. Okay. So that's the